Alright, welcome back. So, this is part 2 of chapter 1. So, in the last session, we went through modules, and this half we'll be going through packages and Pip. And Pip stands for Python Installation Package. So, what's a package? Well, a package is a system of gathering modules and functions together and bundling them up. So we know how we group functions together and package them into a module. When we gather multiple modules together, it's called a package. And when you actually call the functions and that, you basically go through a directory type structure where you call the package, the module, and then the function, but more on that as we get into it. So a package can be created and imported just like a module can. So modules go through a semi-compiled stage where basically when you start up your program, it sort of loads it up and does this quasi compiling, and this allows Python to execute those faster. It's also during this stage that it does a quick check on the source code of the module to make sure that it's still all intact and there's no issues there. Now, this will happen each time, and it uses this process so it can initiate all of the variables and the values that are in the module, and there will be a name variable created, and that file basically is a variable of the main, and it basically matches the name of the file. So the py file, it's just going to use the front half of the name. Now, if you're not on a Windows machine, this comment may have alternative functions. So if it's derived out of Unix, so that means Linux, Mac OS, it's actually an executable content. So what it's doing is it's telling those systems how to interpret this file and set up the environments that it needs to set up. But if you're in Windows, it basically just ignores that bit. So when Python is executing, it is using a directory structure or folder system, and it needs to know what that pathing is, and files need to be within that path because it uses the path to do its searching. So when you call a module, it's got to reside within this path variable, and path, you'll be able to find what it is as it's part of the system module. so you can actually execute it and find out what it's been set as. And as it's a variable, you might want to modify it. So, I recommend you go off, fire up idle, just run this little short command, and it'll give you some form of results. Now, depending on your username and all that, I've just put a generic users in there because it's a variable that will change depending on which account you're logged in as. And the pathing structures, you should have a generic set, and then the top line there, it was my good old module that I was running in the background at the time. So this will change a little bit depending on your setup and the version of Python and so forth that you got. Now, I'll give you a hint. At the time of me doing this, I was running Python version 3.9. Currently, it's version 3.10 if you download it today. So, you can change your pathing with the append and insert methods that we've covered so far. So, it's like a list. We call that using the module name, and it's separated with a dot and then the function name. So that's how we've been calling functions for modules up until this point. Now, when we want to gather modules and packages together, we just add those module names one after the other, separated by the dot. And you work your way down through the folders to the function that you're after. So when you package things together, it's still following that name structure as you go through. So just think of it as opening each folder in the steps down to where your function is stored. Packages require initialization, so they will create an init file, and you'll find that little naming convention exists in the packaging folder. So the path needs to indicate where your packages are for you to be able to import the modules within the package. Now, one of the nice things that you can see is you can have your zip files of your Python code still zipped up, so you can save that hard drive space or transmission, because Python will look at a zip file and consider it as a normal folder and just step through it like it would any other folder. So the great package installer, Pip. So there is a nice centralized repository of packages that people have put together this is an open source library, if you like, and you can get tools and other modules from this, and this is known as the Pi index, package index. So it can be found at pypi.org, and you can browse through it, have a look at it, and make use of it in the programs that you are developing. It is also referred to as the cheese shop, again harking back to the original source of the name, Monty Python sketch. So you need to have pip installed in your packages to be able to access this shop. Okay, so if you don't have the pathing correct, you can't execute pip because it can't find it. Now you're going, why are you mentioning this? It took me a few minutes to get my pathing correct on my machine. So we'll go through and check, and it'll tell you, Python will tell you if it can't find expected modules when you do these checks. So on a Windows machine, you may use the easiest method and reinstall and check it again, or you might just go into your environments variables in the Windows system files and just add the required path to your environmental settings. So how do we go about it? Well, kind of depends on which operating system and version. Simplest way of doing it is in Windows, opening up a command console and typing in pip, the double dash version, and if it's able to find the pip, it'll come back and tell you what version of pip it's running and where it's located. If you get the second message, that's the one I got, and that means your pathing's not correct. So as I said, there's two recommended ways of doing it in Windows. Reinstalling Python to try to get Python to fix its pathing, or go through and do that lovely environmental change yourself manually in your operating system. Linux can run two versions simultaneously, and you can execute version 2 and version 3 by just adding the 3 on the pip command if you've got them running concurrently. If you've only got the one version of Python running on your machine, then generally speaking you only need pip. So how do you go about getting it on there if your version of Linux hasn't got it already there? Well, you go in and make sure your lovely version's in there, and again you might have to update the application to get all of the elements downloaded and installed. So basically perform an update. Now, as you can see from that lovely little graphic on the side, we can import what we want to make up what we want to build as a package. So our final product's up the top, and the various steps to build up the total package is shown as steps as we go down. So for us to run red suspenders using the graphic as the reference, we need to have all these dependencies that it imports from underneath it. So Pip can discover, identify, and ensure that all those dependencies are available to you when you go to execute. Now, Pip's a very useful program. If you want to delve into it a bit more, you can just look at what commands are available with the Pip Help prompt, and you'll get a little listing like this. So Pip uses a very simple command structure. You have the pip, the command, and then any options. If you want to know specific information about a particular command, you use the Pip Help and then the specific command you want to know more about. And for those that are going to do the test later on, I would hazard a guess that you may want to know a few of those out of here, like install, download, uninstall, list, show might be useful. Not that I'm giving any hints away, because we'll talk about them shortly. So, what packages are already installed? Use the pip show command, and that will give you information on those installed packages. What information it is extracting from the package has to be entered in there by the creator. So there is a set form of data that's got to be entered when you create a package. And this is what's displayed by this command. Part of that at the bottom is it will tell you what is required by the package for it to successfully function. And if this package is required by something else, it'll be under the required by listing. Now, this will only be accurate if the user has put in the information to the best of their knowledge. And it will require them to come back and update it if things change. We can search for our packages with the pip search, and then any string is our string that we want to search for. So basically looking for the name of the package or something in the summary of what packages are there, and I'll come back. You can do the search via web-based rather than command line in a console. Okay, this is where a few people might get hung up, is pip is running through your console. Alright, so you gotta get into that shell or console window and run it. Or if you're in Linux, it's just going to be off the command line. Bit of fun. Pygame. So this little package, and it's called Pygame. Install it with pip install Pygame. It'll come up and do that lovely install bar. And if you want to only make it available to a particular user, then jump into the user and use the pip install --user parameter, and that will only make it available to that user. Whereas if you do the straight pip install Pygame, it'll make it available to everybody. To have a look of what Pygame is going to do and what it's all about, you can have a look at the pygame.org website. It's a bit interesting. I want you to break it up. I know it's a little bit intensive with this particular one, but let's have a bit of fun and go have some light entertainment with some of the classic games that have been converted and made available from the community. Okay, so things to remember. Pip can install and update packages. So to execute an update on a already installed package, we use the -u in the command structure. So pip install, and then the package name will be a install function. If it's already installed and you want to update it, you basically insert -u after the install command, and this tells it that it's an update, so it's going to check the version that you have already installed and go check for any changes and then download those changes. So that will update it to the current version. If you need a specific version of a package, you need to change the syntax of the command. So pip install, the package name, =, and then the version. That way it'll install that particular version of the package rather than the most current. Uninstall removes packages from your system. Pip uninstall and the package name that you want to remove. Remember, there's a lot of resources available from the Chi shop. So adding and removing packages is commonplace as you experiment and work out what works for you in the situation. There's no point in trying to reinvent the wheel every time when we have this fantastic community available to us contributing to this library. So have a look in the library, see if somebody's got it already done or something close to what you want, and then take that and modify it and add back to the community. So, good news is we've hit the end of the chapter. Alright, so we had a look at what a package is. It's just adding another layer of bundle. So we bundle functions into modules, and then we bundle modules into packages so that we can get the functionality in the program that we want to achieve. Pip is Python's installation of packages application that's inbuilt, and this allows us to add those bundles into our programs, and it does a little bit of checking and enables us to custom our installation to our requirements and our functionality that we're after. Alright, so that's it for now.